Hello, everyone. This is a course project for machine learning foundations for product managers. Let's look at our problem statement here. So here we have to predict the energy output of a power plant, and that is based on the available data that we have with us, which is provided by this data source, if you can see here. And how we are going to do this, we have been provided with total observations which are around 9,500. And I've divided this into training data and testing data. And my training data would be approximately 7,600, and the remaining data I would use for testing data. I would be using regression in this, and the reason for this is we have been provided with structured data with predetermined fields or features. And we will be using supervised learning, specifically regression, because we are trying to predict an output variable when we are given the observations and features. So let's look at the data here. So we have four features here: temperature, exhaust volume, pressure, relative humidity, and one target variable, which is net energy. Now, for the regression to work, the relationship between the input variable and the output variable should be linear. So I've tried to check that with scatter plots here, and uh, these are my scatter plots between net energy and temperature, net energy and exhaust volume, energy and humidity, and energy and pressure. Now, if you look at this scatter plot, it is not really linear. So we are going to try some combinations. We'll start first with simple regression, and then we'll use combination of features to verify which model will work best for us. There is another data prep a step that I've used, and that is to find out the correlation between the features or input variables that we have. So if you look at the values here, this is correlation between temperature and volume, and other other values are okay, but this looks a bit significant, and it indicates that temperature and exhaust volume are about 84% correlated. Now this is my data here, regression which I've performed around 7 models. So I've done some single variable regressions here. So this is the summary output when I have used temperature as a variable. And if you'll see our standard error value here, it is 5.4. Our R square here is 0.9. Our adjusted R square is 0.89. Similarly, these are the regression outputs with the various single features. I have also done regression with 2 variables combined, so temperature and pressure. And the standard error here is a bit less, which is 5.35, but our R square and adjusted R are 0.9 here. Then coming to the regression with 3 variables, we have better standard error value here of 4.87, and better R square and better adjusted R. Finally, when I use all the 4 variables, I get the best standard error output, which is 4.52, and my R square and adjusted R are also have also improved. I plotted them here so we can compare them easily. And these are my observations, which are about 7,600. And I've also verified this using my test data. I put the results here for the last two models here: temperature, pressure, and exhaust volume, and all the four variables, where I also include humidity. And if I run it on my test data, which is about 1970 rows, then if I check it for model 6, and I compare it with the actual output and the predicted output, and this is my absolute absolute mean mean absolute error value. For model 6, I get it as 3.89. And for model 7 here, which is where I'm using all the four variables, I get it as 3.67, which is slightly less than 3.89. So these definitely are better numbers. The R square value here is better. Standard error is less than 4.87, it is 4.52. So this will be our final model, and um, it's the conclusion. So that concludes this recording, and thank you so much.